A warm greetings to you all. So now I am going to discuss about petroleum and petrochemicals in this session. I have already uploaded the video in which I discussed in detail. So I am calling it as a revision class. So first we will see blow up of the syllabus. So one, we have to see source. Where do we get petroleum? So petroleum is a dark greenish brown viscous oily liquid which is found deep in Earth's crust below several thousand feet. Okay, and it is extracted or it is lifted up through a process is called as mining. So we are going to mine it. So mining of crude oil or petroleum is done by drilling holes in the Earth's crust and sinking pipes into the oil bearing porous rock. So what happens? So the crude oil usually gushes out itself due to the hydrostatic pressure of natural gas. Okay. And next is composition and classification. So main composition of petroleum or crude oil is hydrocarbons like straight chain paraffins, cycloparaffins, naphthalenes like this. So the average composition of crude oil is carbon. Mainly carbon will be present. So carbon will be of 80 to 87 percentage, and the next is hydrogen. So that is why I said the main composition of petroleum or crude oil is hydrocarbons. Hydrogen will be of 11.5 to 15 percentage, and some traces of sulfur and nitrogen and oxygen will also be present in petroleum or crude oil. So how we are going to do the classification? So mainly three types. So three principal varieties we will observe. So one is paraffinic based type crude oil, where we will have paraffins, that is naphthalenes and aromatics will be in more number, and aspartic based type of crude, and the third type is mixed based type crude oil. Okay, so next is petroleum refining. So the crude petroleum has to be processed or refined before being put to the commercial use. So the process of separating crude oil into various useful fractions by fractional distillation and finally converting it into a desired specific product is called as refining of crude oil. Okay, so main steps involved in this is the step 1 is separation of water by Cottrell's process. Okay, so the extracted crude oil or petroleum oil, it contains water, so that water has to be removed. So what we will do, we will allow the extracted crude oil or petroleum to flow between two highly charged electrodes. Then colloidal water droplets coalesce to form large drops of water which separates out from the crude oil. And in the second step, removal of harmful sulfur compounds will be done. So we are going to treat the crude oil with copper oxide. So when we treat with copper oxide, so copper sulfide is formed and copper sulfide is removed through filtration. And the third step is fractional distillation. So here the crude petroleum is heated to about 400 degrees centigrade in coiled pipes kept in a gas heated furnace. Okay, so all volatile components are evaporated, leaving behind the residue of the coke. The vapors obtained are then admitted into a specially designed fractionating column. As the vapors go up, they become gradually cooler and fractional condensation takes place at different heights of fractionating column. So higher boiling fractions condenses first, while the lower boiling fractions condenses turn by turn at a definite temperature range. Okay, so at a 30 degree temperature, uncondensed gas is obtained, and between 30 to 70 degrees centigrade, so petroleum ether is formed, and between 90 to 120 degree, gasoline or petrol is formed, and naphtha or solvent spirit is obtained between 120 to 180 degree. So like this, so different fractions of petroleum is going to obtained. Okay, and next is about cracking. So the process of breaking down the less volatile higher hydrocarbons, that means so less volatile or volatile means so which can easily change into gas. Okay, so less volatile means so those petrol will not have easily changing property into a gas. Okay, so process of breaking down the less volatile higher hydrocarbons from petroleum into different types of more volatile lower hydrocarbons is called as cracking. So mainly there are two different types of cracking. So one is thermal cracking and another one is catalytic cracking. So thermal cracking can be done in two different ways. So one is vapor phase thermal cracking and another one is liquid phase thermal cracking. And in case of catalytic cracking also, so two different methods are there. So they are, one is fixed bed catalytic cracking and another one is called as moving bed catalytic cracking. Okay, and next is a synthetic petrol. So synthetic petrol is done by two processes. One is Burgess process and another one is Fischer-Tropsch process. Okay, so since the ever increasing demand for petrol and the limited sources available for the supply of it has stimulated attempts to synthesize petrol from alternative sources. Okay, so this is what is about synthetic petrol. And next is about knocking. So the petrol and diesel are largely used in internal combustion engines. So the fuel consisting petrol vapor and air is compressed and burnt within the cylinder of the engine. So the initiation of combustion reaction takes place by a spark in the cylinder. Okay, so there are two kinds of internal combustion engines. So one is the spark ignition gasoline engine and the other one is the compression ignition diesel engine. Okay, so most of these are 4-stroke cycle engines. So these combustion engines are 4-stroke cycle engines. That means so 4 piston strokes are needed to complete a cycle. And just you can imagine our motorcycle or motorbike. So it is also will have 4-stroke. So the same sort of combustion engine is discussed here. The ratio of the gaseous volume in the cylinder at the end of the suction stroke to the piston is known as the compression ratio or critical compression. So how the chemical structure and knocking are connected with? The knocking property of petrol depends on the chemical structure of constituents. So the tendency of fuel constituents to knock is in the following order. That is, straight chain paraffins will have higher knocking property than branched chain paraffins, and branched chain paraffins will have higher knocking properties than olefins and cycloparaffins and aromatics are in this order. So thus the aromatic constituents have least knocking property and straight chain paraffins have highest knocking properties. As the chain length increases, knocking property of alkane increases. The branched chain alkanes have lower knocking property than straight chain alkane containing same number of carbon atoms. For example, so here N-octane have a better knocking property compared to the iso-octane. So the compression ratio at which knocking results depends upon the nature of the fuel. It is therefore important to determine the so-called anti-knock value of a fuel. The anti-knock value of petrol is expressed in terms of octane rating or octane number, while CETANE rating or CETANE number is used to rate the diesel fuel length. So now we will see what is meant by octane rating or octane number. So it has been observed that N-heptane knocks very badly, or it has anti-knocking property lower than any other gasoline fuel. So therefore, arbitrarily, so for this N-heptane, so the octane number is kept as 0. On the other hand, iso-octane, that is 2,2,4-trimethyl pentane, gives very little knocking, so its anti-knocking value has been given as 100. Okay, so how we are going to do the rating here is, so we are going to make a linear scale, that is n heptane is taken as the octane number is equals to 0, and for isooctane, so we are going to take the octane number as 100. So we are going to compare in between n heptane and isooctane. Okay, so let me define the octane rating or octane number. The octane number of the fuel is defined as the percentage of isooctane present, because isooctane is taken as 100. Okay, so the octane rating of isooctane is taken as 100. That is because it has very little knocking property, so that is why it is kept as 100. Okay, so the percentage of isooctane present in the mixture of n heptane and isooctane, which matches the fuel under test in knocking characteristic at same experimental conditions. So this is how we are going to define the octane number. I hope you have understood. I will explain again. So here n heptane is, its octane number is taken as 0, and for isooctane the octane number is taken as 100. Okay, so now to which petrol you want to examine, what is the octane rating of say for example one you will get a petrol from one petrol bunk, and you want to check what is the octane number of that particular petrol which you have taken from that petrol bunk. Okay, so you are going to compare that fuel with, means you are going to test how much of isooctane is present in that petrol and how much of n heptane is present in that petrol. If you have more percentage of isooctane in that petrol, then it is more efficient. That means then it has high anti-knocking property. If n-heptane itself is more compared to the isooctane, so then it has very less anti-knocking properties. And okay, so this experiment should be done in the same experimental conditions. For example, 80 octane fuel is one which has the same combustion characteristics as 80:20 mixture of isooctane and n-heptane. Okay, higher the octane number, the better the fuel is. The ordinary petrol has an octane number 30 or more. Aviation gasoline used in aeroplane has the octane rating of 100. At present, hydrocarbons with octane number greater than 100 or smaller than 0 are also known. Okay, so beyond this n-heptane and isooctane, we have some fuels which have the octane number less than 0 or higher than 100. For example, 2,2,3-trimethyl butane, that is tryptane, has an octane number of 125, while n-nonane has an octane number which is less than 0. Next is the structure of hydrocarbons and their octane number. The octane number of hydrocarbons depends upon nature and structure of hydrocarbons present in the fuel. It can be summarized as follows. Straight chain alkanes have lower octane number than the branched chain alkanes of same composition, and octane number decreases as the chain length increases. Cycloalkanes have higher octane number than the corresponding acyclic alkanes, and alkanes and aromatic hydrocarbons have higher octane number than the alkanes. So this is the reason why petrol obtained by cracking is more effective than petrol obtained by straight distillation. And next is how to do the improvement. That means as till now we discussed that if we have the anti-knocking property for that fuel, so then it is more efficient. That means the octane number will be more. We are going to measure the anti-knock property with the help of octane number. So how to increase it? So there are two types of petrol. One is leaded and another one is unleaded petrol. So as the name itself says, leaded means we are going to add the chemical lead to it, and for unleaded we are going to use some other chemicals which is not a derivative of lead. Okay, so why we do this and what are the advantages and disadvantages of this, we will discuss now. The octane number of petrol can be raised See, this is what I told. So we can rise the octane number. So if we rise the octane number, what does it mean? The percentage of isooctane is increasing. That means isooctane we have kept as 100. No, so if we add certain chemicals, so the percentage of isooctane is going to get increased. So what are those chemicals? Is one is tetraethyl lead. We also call it as TEL, and another one is diethyl telluride. Okay, so these are the two chemicals which we can use to rise the octane number of the petrol. Say for example, in motor petrol, that is what we will use for the motors, about 0.5 ml, and in aviation fuel 1 to 1.5 ml of tetraethyl lead is added per liter of the petrol. And okay, so how it is added, how the reaction takes place. The mechanism of increase of anti-knocking character by the addition of TEL can be explained as so first what we are going to do is, so first so this tetraethyl lead TEL is converted into a cloud of finely divided lead oxide particles in the cylinder. So these particles react with the any hydrocarbon peroxide molecules formed, and thereby slowing down the chain oxidation reactions. And okay, so the lead oxide is deposited on engine, so which reduces the life of the engine. So for this reason we have to remove the lead oxide simultaneously. So what we are going to do is, so we are going to react that lead oxide with 1,2-dibromoethane, and then so the lead is going to get converted into lead bromide along with the exhaust gas. So this is a simple reaction what it is going to take place when we treat lead oxide with 1,2-dibromomethane. Okay, so what are the disadvantages of leaded petrol? The deposition of lead oxide or litharge on the inner wall of cylinder jams the piston. Okay, so the piston will get jammed. So definitely if the piston gets jammed, means the efficiency of the engine will get reduced. So this lead oxide will attack or will go and deposit on the inner walls of the cylinder. So this is one major advantage. And another one is the efficiency of TEL is reduced by the presence of sulfur compounds in the petrol. And the next disadvantage is the leaded petrol cannot be used in automobiles equipped with catalytic converter. And the last disadvantage is the lead is added as pollutant to the environment. Okay, so these are some of the disadvantages of leaded petrol. So for this reason, so alternatively, octane rating of petrol is increased by adding compounds which have high octane number like methyl tertiary butyl ether, isopentane, isooctane, ethyl benzene, isopropyl benzene, etc. So without using lead derived chemical compound, we are going to use some other compounds, so that is methyl tertiary butyl ether or isopentane, like this. So those will reduce, or those will not show the disadvantages what has been shown by the leaded petrol. Say for example, so in the last disadvantages we saw that the lead is added to as a pollutant to the environment. So we have to see, so the environment also should not get spoiled. So for this reason, so one of the best chemical which we can use is MTB, that is methyl tertiary butyl ether. Why? Because so this contains oxygen in the form of ether group, and it supplies oxygen for the combustion of petrol in an internal combustion engine. So this will reduce the extent of peroxy compound formation. Thus unleaded petrol is one in which the increase of octane rating is accomplished without addition of lead compound. Okay, so what are the advantages? So the major advantage of unleaded petrol is that it permits the use of catalytic converter attached to the exhaust in automobiles, and it also oxidizes unburnt hydrocarbons into carbon dioxide and water, and extent of pollution is reduced. Okay, and next is a CETANE rating. So as I told, CETANE rating is a method which is used to know the anti-knocking properties of diesel. So the quality of a diesel fuel is expressed in terms of a CETANE rating or CETANE number. So here also what we are going to do is, so we will have a linearity. That means we will consider one chemical or one compound as a which has an octane number of 0, and another one has which sorry C10 number has 0, and another one C10 number having 100 anta. Okay, so this will be done with how it is going to ignite in a rapid way in an arbitrarily form. So we are going to give the C10 number anta. Okay, so in this the n-hexane or decane, so n-hexane or decane, so which ignites rapidly is arbitrarily given a C10 number of 100. Okay, so this is what is n-hexadecane or C10, we call it as C10. So this is taken as the C10 number is taken as 100, whereas this one, the alpha methyl naphthalene, so which ignites slowly, is given the C10 number 0. Okay, so the C10 number of a diesel fuel is defined as in the same way how we defined for octane rating, in the same way. So the percentage of cetane in the mixture of cetane and methyl, that is this one, alpha methyl naphthalene, which has the same ignition quality as the fuel under test at the same experimental conditions. Okay, so a diesel fuel having C10 number 60 would have a same ignition matching as that of a mixture of 60% C10 and 40% alpha methyl naphthalene. Okay, depending on the C10 number, diesel fuel is divided into three types. The first one is high speed diesel. So here if the C10 number is 45 to 60, so they are classified as high speed diesel, and medium speed diesel will have up to 35 C10 number, and low speed diesel will have up to 25 C10 number anta. Okay. And next is a reforming. So this is also, reforming is also another way to improve the anti-knocking property of a fuel. So here what we are going to do is, so reforming is a process of bringing structural modifications. So we are going to change the structural modifications. Say for example, if it is a straight chained alkane, then we are going to convert it into a branched chain, or if it is a straight chain, then we are going to cyclize it, we are going to convert it into a naphthalene like structure. So we are going to alter the structural modifications of the hydrocarbons which is there in the fuel. Okay, so this is mainly done to improve the anti-knocking properties of the fuel. So it is carried out either thermally or in the presence of catalyst. So the first method of reforming is thermal reforming. So it is carried out in a reactor or a heater. The gasoline is heated to 500 to 600 degrees centigrade under pressure of 85 atmospheric pressure to avoid the formation of gas at an expense of gasoline. So the condition of gas at the expense is the condition of gas is controlled by quenching the products by spray of cold oil. So what happens during thermal reforming? So as I said, N alkanes are going to get converted into a branched chain alkanes, and some cracking also occurs here. So cracking means say for example n-hexane or n-decane can be converted into n-pentane, so that it will increase the volatility, and it will automatically get high anti-knocking properties. And the next thing, these alkanes and alkenes undergo dehydrogenation, which is followed by dehydrocyclization to yield naphthalenes. The reformed products are then fractionized to remove residual gases. Okay, so this is what is thermal reforming. And the next is catalytic reforming. To get better quality and yield of gasoline, catalytic reforming is carried out by using platinum supported on alumina as catalyst. Okay, so here this catalyst is very important. So the chemical transformation or the structural modification is going to take place with the help of platinum and alumina, which has been used as a catalyst. Okay, so the process is carried out at 460 degree to 530 degree centigrade at 35 to 50 atmospheric pressure. So these are the chemical changes or the structural modifications which are going to take place in the presence of these catalysts. Let us see one by one. So the first one is dehydrocyclization. Okay, so here when n-heptane is treated with platinum and alumina as a catalyst under certain experimental conditions. So here what happens is a removal of hydrogen molecule is going to take place, and this hydrogen molecule, when it gets removed, we are going to get methyl cyclohexane. Okay, so further if we treat this compound with the same catalyst and proceed the reaction with under certain experimental conditions, so here three molecules of hydrogen molecule is going to get eliminated to give toluene anta. Okay, so in the same way dehydrogenation, if we take cyclohexane and under certain experimental conditions, if we treat platinum supported alumina as catalyst, so here also the three molecules of hydrogen is going to get eliminated or liberated to form benzene. This reaction is same like what I have explained here. In the same way here also three molecules of hydrogen will be liberated or eliminated to give toluene. And hydrocracking, so this is just like how we will do cracking process. So here n decane in the presence of catalyst, so all these reactions will take place with the help of using platinum supported on alumina as catalyst anta. Okay, next is isomerization. Even isomerization can also takes place where NXN will be converted into 2-methyl pentane. So these are the chemical or structural modifications which will takes place with the help of catalyst. So that is why it is called as catalytic reforming. And next one is petrochemicals. So petrochemicals are an essential part of the chemical industry, and they touch almost every aspect of our material civilization today. Chemicals obtained either directly from cracking or indirectly from chemical processing of petroleum oil or natural gas are called petrochemicals. Okay. The important petrochemicals which are obtained directly by cracking and indirectly by chemical processing are given in this table. So methane, ethane, ethene, propane, propene, butene, so all these are obtained by direct cracking, and indirect petrochemicals which are obtained by chemical processing are methyl chloride, methylene chloride, methanol, chloroform. So that means so if we take this methane and if we do some chemical processing either by thermal reforming or chemical reforming, so we are going to get the indirect petrochemicals which are obtained by this methane, that is methyl chloride, methylene chloride, methanol, chloroform. In the same way, so if we do the chemical processing to ethane, we can get ethyl chloride, ethanol, acetic acid, and ethene also will give ethyl chloride, ethanol, glycol. Likewise, so we are going to get indirect petrochemicals. And alkanes isolated from petroleum containing 6 or more carbons can be transformed into aromatic hydrocarbons like benzene, toluene, etc.